Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So in today's video, as you can tell by the title, we will be discussing something that I haven't made a video on about in around a year, but I have been doing these videos annually for about the past, I would say, 4 years. So yeah, definitely at this point it's a kind of a tradition on this channel. But yeah, we'll be talking about or when can you expect to see your first snowfall this year. I want to preface this right off the bat that again, it is very far out, and it is most likely going to have quite a bit of inaccuracy. But again, this is more for the fun of it. This weather channel in general is not really for official information. That is always the National Weather Service, National Hurricane Center. That's where you should go. This channel, you could watch it and see what I have to say, but again, mainly, these type of videos especially is just for the enjoyment of myself. I like making these maps, and of course there are people that enjoy watching this, as I found out several years back, and ever since it's been growing. So yeah, if you guys do find this video fun, cool, interesting, consider subscribing, consider liking the video. And if you are a returning viewer, obviously hitting the thumbs up button would help out a ton. If you're a new viewer, that would help. Leaving any comments or concerns down below, I will answer probably all of them, so leave them down below. Okay, let's start talking about this. So first off, in order to figure out the question that I'm asking today in today's video is, well, what's the ENSO situation? If you don't know what the ENSO is, it stands for the El Nino Southern Oscillation. You can see right there. And whether or not it's below or above average, it indicates a lot about the weather. Yes, it's a rather abstract concept, but it's been proven many times to hold true. So the ENSO is referring to this region across the equatorial Pacific Ocean, and whether or not it is 0.5 degrees negative or 0.5 degrees positive and above, that's an El Nino when it's warmer, or a La Niña. And if it's somewhere in between, then it's a neutral. And right now, we are in a neutral. We are expected to go into a La Niña. And you can see that the ocean waters here, this is the current anomaly, are a bit cooler. Not cool enough to consider it a La Niña, but they are cooling off. They definitely are cooler than they were during the summer. And it looks like the forecast for a La Niña still is in place. So what does this mean? How on earth can these waters over here impact our weather? Well, the short answer is can impact it quite a bit. But before we get into that, I do want to show you quickly what the models are showing and more information about the actual prediction of that water temperature. So notice, right, we were in a La Nina last year. Usually I refer to La Nina winters as years of extremes. That doesn't necessarily mean a cold and snowy winter. There have been La Nina years like 2011, 2012 where there were heat waves, very early severe weather outbreaks, very little snow, but that's considered still an extreme. There have been years like last year where, the south, the Texas just freezes over. My area got 36 inches in 3 weeks, right? So these extremes, again, each winter is slightly different, but it does seem to hold on to a trend of being a extreme. So not really a good thing. But notice that again, the Climate Prediction Center, a very reputable source through the years, has the La Nina developing at really a confident 70%, especially around the December, January, November timeframe. It does die down a bit as we head into spring, and notice that yes, we are still in a neutral, but at this point in time, we may already be in a La Nina. They update this really just once a month, so it is I think the second Thursday of the month is the day when they do it. And right now it's the first Thursday of the month of September. And this is a model outlook, so just individual models. And again, this is kind of the ocean temperature anomalies. Notice this is a half a degree below average. Here's half a degree above average. This would be a El Nino. You could see one model shows that, so that's not very many. Quite a few are, according to this model group, showing a neutral. But again, I've been observing these models for the past several weeks, and they are trending a bit towards the La Nina. Overall, this group of models is not as accurate as I would say this one is. Notice this one does have more of them in the La Nina range, and again, it makes sense if this one's a more accurate one, as there is a La Nina watch issued. So that means that the Climate Prediction Center, the organization, thinks that, well, there's a pretty darn good chance for a La Nina, and that's why, again, that group of models is a bit more accurate, as that first one I showed you. Really, it's split half and half. But I want to scroll up and show you. There we go. Look at that, the La Nina watch. ENSO neutral conditions are present, but again, they are favored to develop into a La Nina. And yes, they're updated second Thursday of each month. So that is next week. We will have another update on it. But regardless, that won't really change anything significant because we'll probably stay on schedule. If it is something that is a bit unusual, I obviously will make an update video on. So I showed you the sea temperatures again, and you may be still wondering, okay, so you've proven the point. It's most likely a La Nina. What's this gonna, how does this impact the United States? Well, what I basically did was I looked at years that were prior to, first off, I think we could learn a lot about things in general from our past, right? And especially regarding the weather. It's called analog years, and similar patterns always tend to hold similar truths and similar observations. So I showed you this graph earlier of all the years, right? We came out of a La Nina, went into a brief neutral, and went back into a La Nina. And what I did is I chose many years that did similar kind of performances with the ENSO. So I chose years that didn't necessarily come from a La Nina, but transitioned from a neutral summer to a La Nina winter. And the first year, like you could see, is 2017, 2018. Actually, no, last year was really the same. It came from a El Nino winter, but that was 2 years ago, and there was a bit of neutral. So you can see if I were to put everything exactly the way it's supposed to be, from a exactly mimicking this year, there would probably be 1 or 2 years, which isn't really enough to see any sort of pattern. So I just did a neutral summer into a La Nina winter, which most likely will happen this year again. So I wanted to take a look at those years and see what their temperature was and what their snowfall was. So let's start talking about that. And in order to do that, I'm going to pull up this slideshow presentation. Hopefully you could see this pretty well. And notice that right off the bat, what we see is from last year. So last year, pretty recent, right? December through February. Overall, not a brutally cold winter. Obviously, there were memorable parts of it, especially that cold outbreak across Texas, which really, again, made that anomaly for the whole winter. This, you can see it's 3 months. Go below average. There were many cold days across my area, but it wasn't really, it was kind of mimicked and mirrored by many warm days. So overall, it was rather average, but definitely above average in snowfall and whatnot. So you could see it's definitely not favoring warmth so far. What we have from this pattern, if you will, the neutral to a La Nina. Sorry about that. Then December through February of 2018. It's cut off right there. I'll readjust this so you guys could better see this. Now you should be able to see that December through February of 2018. And notice right there again, that's another year that went from a neutral into a La Nina, not that long ago. And the whole winter, well, where it was warm was maybe towards the southwest and maybe the southeast. But where it was cold was similar areas. You could see Texas, the south, right? And also this year, or this 2018 year, introduced a cooler northern United States and southern U.S. So definitely something that is interesting. Again, more really of that cold rather than that warmth on the U.S. soil in southern Canada. But definitely a definite factor of that warmth is appearing. Let's go back to more years. 2008. What do we see? Well, if you've noticed through the years, a lot of them, so far the 3 ones, focus some chilly air across the north, southern Canada. Not all of them show a cold weather across the southwest. You can see this one does, this one doesn't. This one actually shows a bit of warmer temperatures towards the south. So you could see, but that's what we have for 2008. Definitely not an all-out warm winter, right? None of these winters have been. It's been rather more cold than warm for all 3 years. Even if the Southwest was warm on this year, the rest of the U.S. was chilly or average. And let's continue this forward. Now, this was a year that was slightly different. Again, not all the years are going to be the same. That's why, a pattern in the weather history usually is hard to see, or hard to find, and really not often. And if they do appear, then it's something that is exciting because that indicates some sort of coincidence, which there isn't any sort of thing called coincidence in the weather. It's called a pattern, right? And that's what we're looking for. And right now, you can see this one doesn't agree with anything. It really shows an all-out warm winter. Not terribly warm, but you could see that the anomaly is there, 0.5 degrees. That is definitely a noticeable increase, and really just Florida being cooler. However, I want to say that this was not the only year that was warm. Look at this next year that I want to show you, 1999. This was again, a year that was very similar to what we're seeing in terms of the ENSO development, right? Just like all the years I've chosen here. And again, as I mentioned, some of these La Nina years are warm, some of them are very cold, some of them are snowy, and again, this is just the temperature anomaly, and you can see already the variance. This one, again, showing very warm conditions, even warmer than the 2006 winter, and where it was chilly was across the northwest and portions of western Canada. In this map, I guess you could argue the same if it was cooler or closer to normal. It was across the southwest, or sorry, the northwest and southwestern Canada. But yeah, you could see this year definitely was warmer. However, again, for every warm year there was a cold year, and you could see 1985 was a brutal year. And you can see some of these anomalies are very, very extreme, especially as you get into southern Canada. But again, notice it's kind of focused on northwest where it is cold and the southern United States. And I think I have one more year, yep, 1983 to 1984. You could see it was cooler. Really, this is a bad graphic because the interval is -4, so we can't see the detailed of 1, 2, 3. I'm not really sure why this did that, but definitely if you were to probably divide this up into smaller intervals, it would be cooler temperatures. Sorry, no, because this goes by every. This is 4, this is 6, this is 8. So there could be, there could be areas. We don't see any areas that are between +2 and -2, below or above average. So that's probably the majority of the northern U.S. where it's chillier. And I would assume that if it were to show 2 degrees above average, which it doesn't on this map, it would probably be somewhere across the southwest. But yeah, you can see definitely more of a chilly year than a cold year. Or a warm year. Now this is again just the temperatures, but I think what I showed you here, yep, is all these years averaged out. So all the ones I showed you, December through February, and you could see that if it is cold, it's most likely to be the worst across the northwestern and northern U.S. and into southern Canada, southwestern Canada in particular. And if you're to take a look up right now, just La Nina typical pattern on the internet, the cold air where most of the graphs show it is, well, where the cold air is on this map. So, that's good. We see a pattern, and, La Niñas seem to have that. If it is cold, it's colder across those locations. And notice there is a exception for Texas. It is also seemingly chilly there often for an apparent reason. Notice the Southwest is warmer on most La Nina years. Again, that isn't always the case, as if it's a year like 2006 or 1999, it's warm just about everywhere. So it's tough to tell whether or not it will be a cold La Nina. Right now, I would say it's going to be an interesting year, right? I would say that there's going to be definitely cold outbreaks, many of them. Will it be enough to, kind of grant it the title of a cold winter? It's hard to say. There could be also as many heat waves as cold outbreaks, and that is also, overall just not really the best news, because an extreme winter full of extremes, either way you put it, severe weather or large blizzards, isn't the best case scenario. So now I want to look at precip. I didn't show individual years, but this is what the precip of all the years averaged out. Notice there are some remarkable trends. It's where the Great Lakes and the Northeast, it's rather wetter, and if it was cooler, then it would be snowier. Same thing with the Northwest. If it was cooler, which this graph shows, and much wetter, that would mean more snow. The Southwest, unfortunately, is usually a bit drier during La Nina years, and Florida seems to often get in on some of the drier years as well in portions of the Southeast. Unfortunately, with the video title and what I'm kind of trying to answer the question of, it's when to expect your first snowfall. And the U.S. is big. You probably know that, and I also do southern Canada. So at this point, the first snowfall, I showed you all the winter months, because for many usually it's December or November, which is more of the winter. But for some, it's September and October, which is more of the fall. So the information I showed you there really isn't that relevant, which is why I also prepared a bunch of slides for the fall. And you could see that during those same exact years, I will hurry up during these slides because I don't want to take as much time as I took for the winter kind of months. But for the September through November, I chose those years, those months of all the same years I showed you. And I wanted to see how the falls compared to the winters, right? And see if there's any overlapping. And obviously, if there's overlap in warm or cold air, then, that's obviously a bit more confidence is placed in that. But this was last year. If you recall, the winter showed cooler air, and you could go back a few minutes. The winter was cooler further towards the south and into Texas. The fall, yeah, you could see rather warm. 2018 winter was more on the chilly side for many, especially across the Northwest. You could see the fall, yeah, it was rather warm. So notice that, again, there's a bit of counterintuitive information here. You may think that, oh, if it's a colder winter, it's a colder fall. And often during La Nina years, that's not the case. Sometimes La Nina cold winters are preceded by very warm falls. And notice that there is a cooler scenario here for the south, but still warm for the north, which is where the snow falls during the early part of the fall and winter season, if you will. So again, that would indicate these past 2 years a delayment of snow, that's important for the northern U.S. At least that is. Notice September through November 2005. Look at that again, very very warm across much of the U.S. To the 1998 to 1998, the fall again very warm, and there was one year that was an outlier, 1995, which was a very very cold fall. And I don't think I showed you the winter of this, but it's a very similar graphic. I forgot to include it in here. It was a very very cold winter, but yeah, 1995 is really the only year that shows such cold weather, and you could see 1983. Even this year shows relative warmth, a bit of cool towards the northwest, and then we do have one year that shows more cool towards the northwest. But yeah, you can see that in terms of precip, this is what it looks like for the fall months. Drier towards the south, wetter towards the north and the Great Lakes, the northwest I meant to say. And this is all the years averaged out in terms of temperatures. So you can see a warm fall is more favored. Now this is where, it gets tricky because some years are colder during the fall and they also have a cold La Nina winter. Sometimes, and more often than not, this is true. There's a warm fall and then a cold winter with a La Nina pattern. But then, what's like this year? Under what category does this year fall under? And that's a really hard question, which leaves a lot of room for error. And now I want to show you my final kind of picture that I drew. Yes, it's not the best, but just bear with me here. Again, this is more for the fun of it, and I will explain each category. So, really, I'll first explain my thoughts. So, I think that even though usually La Nina falls are warmer, they often have a lot of these aggressive, sharp bursts of cold air, and usually most fall do, even if they are warmer. And during those bursts is usually when the first snowfall can fall. So, you could have an early snow despite the fall being warmer. This is why it's such a hard question to answer. And really looking at, the fall and upcoming winter and fall months, it's hard to tell just based off what the past temperature was, when the first snowfall will occur. You have a better chance of guessing by looking at the kind of the climate models. And based on recent kind of trends, I still went with an earlier. I think a lot of the northwestern and northern United States will have an earlier than normal chance of seeing snowfall. Again, not necessarily indicating for a warm fall or a cold fall. But I do think that there will be quite a few areas that get some early snow. Not necessarily, commencing winter or a snowy fall, just a quick burst. And that's why I have some of these areas across Idaho and into Montana and Wyoming and Colorado already seeing a snow. That's a category that I kind of coined September 1st through the 15th. So in the next 15 days, I think these areas could pick up some snow. Now in this pink, that's through the 15th and 30th of September. So yeah, you could see I went pretty aggressively with that. And some years that never even happens through, beginning of October. I think this year it will be rather extensive. Doesn't mean that there will be constant snowpack there or it will be overall cold. But I think there will be a chance for that first snow to be early. Now, in this purple, I still went ahead of schedule. I included more of Montana, more of North Dakota, and this is what I would call October 1st through the 15th. Yes, through the 15th, not the second half of the month. And notice that it is, again, a bit, usually southern Montana doesn't see their first snowfall until later in October. But I included it in early part of October because, again, I do think there will be enough cool shots of air to bring in a, cold front, maybe even a snowstorm. But that doesn't indicate that it will be necessarily a warm or a cold fall. Now, in this lighter pink, that is through the end of October. So really, combining these two areas, that's October 1st through the 30th. But yeah, I could even imagine potentially Minneapolis getting some snow before October is done. But I definitely expanded it across the Northwest more aggressively. Again, I think there will be a decent chances of early snow. Now, this is November 1st through the 15th, right? And notice that there is again more locations in here than there typically would be, but I started decreasing it across the Northeast. That is one area where I think it will be a while before the first snowfall does occur, because usually during the La Nina incursions of cold air during the fall, it's more focused across the central and western United States, not so much the Northeast. So that's why I went a bit behind schedule. Many locations across southern Vermont see their first snowfall in November, and I kind of pushed it towards the second half of November, which is this lighter blue. That's why I think Illinois, Chicago, right, Indianapolis, Missouri, Kansas will be seeing it through maybe during the second half of November, and this is still ahead of a schedule for Oklahoma, Texas, Kansas, but it starts getting a bit behind schedule for the Northeast, and that's the trend. Don't pay too close attention to this map. There's probably a lot of flaws. Like I have Las Vegas here seeing snow in this map, and again, that's not really going to be accurate because he usually doesn't see snow. But I just can't put out those fine details on this map. But yes, so I just did think if you're across the west, above average chance of seeing your first snow early, and here across the east, especially the northeast, a below average chance of seeing your first snowfall early. That's why you can see this light. That's pretty much December 1st through the 30th. Yeah, it may be even hard to get the first snow that's accumulating across portions of Virginia and Maryland up until the later part of December, and that's why I really pushed the limits with this and pushed it back a bit. Here it started getting a bit ahead of schedule, but yeah, definitely slowing down. I think the earliest snowfall, kind of from the norm will be across the northern plains, and then everywhere else it should be around average. Again, it may be a bit delayed across the northeast. Okay, guys, so again, this is more for the fun of it, kind of giving you my thoughts. Obviously, if you want a individual city, just kind of comment it down, and I'll give you my best thoughts, because this map is sloppy, but it gives you the regions where it is above and below average of seeing your first snowfall. And I did realize when I was making this video, that what am I referring to as average? I went off this map that the Weather Channel made, and I just searched up average snowfall date map US, and it shows it divides it into whole months. I kind of subdivided it. So yeah, again, nothing really to give more than 2 minutes of thought about, because it's again more for the fun of it. But hopefully you enjoyed. Hope you learned something new. I'll catch you all on the next episode.